Hello everybody, it's Dumplet here, and here's an item on an interesting function. A function f is defined on the positive integer, satisfying that for each n, the sum of f of d, as d ranges over all positive divisors of n, equals n. What is the value of f of 2021? As usual, pause this video if you would like to give this item a try, but if you're done, let us dive into the solution. Now, I already highlighted the primary interest here, 2021. Now, if we would want to get the value of f of 2021, then we might want to try writing n as a sum of f of d. So we know that we can do that since we have 2021 to be a product of two primes, 43 raised to 1 times 47 raised to 1. We know that we can take the exponents, we add 1 to it, so it's going to become 2 and 2. We multiply them, and we would know that 2021 has 4 positive divisors. So we know that we can write 2021 as a sum of 4 f of d's. So 2021 equals f of 1 plus f of 43 plus f of 47 and plus f of 2021. So, in fact, if we can find the value of these three, f of 1, f of 43, and f of 47, we would be able to get the value of f of 2021. So we have two things to know. We have two things that we want to know, f of 1 and f of 43 and 47, which are both prime numbers. In fact, we can try to get the general formula for the f of a prime number. But first, let us start with the basic n equals 1. Now, if n equals 1, note that we can write n, which is given to be 1 here, as a sum of f of d, where d is a positive divisor of n. Now, there's only one divisor of 1, namely 1. So it is already obvious here that we have f of 1, which equals 1, since 1 is the only positive divisor of 1. So f of 1 must equal 1. And we can use this in helping us to get what is f of p, where p is a prime number. So for n equals p, for any prime number p, now we know that a prime number only has two factors, 1 in itself, so we have 1 and p. So f of 1 plus f of p, by the definition in the item, should give us a sum of p. So f of 1 plus f of p equals p. Now, since we know that f of 1 here, that's equal to 1, so we simply subtract 1 on both sides, we're going to get that f of p equals p minus 1. Now, we now know the value of f of 1. Given to be 1, we know what is f of 43. Since 43 is prime, we know it's 1 less than 43, it's 42. And we also know what is f of 47. Since 47 is prime, we know it's just 1 less than 47, which is 46. And thus, we have successfully acquired the value of f of 1, f of 43, and f of 47. So going back, we know that f of 1 plus f of 43 plus f of 47 plus f of 2021 equals 2021. So since we already know these three values, we know 1 plus 42 plus 46 plus the desired value of f of 2021. This will give us 2021. All we have to do is just solve for f of 2021. So f of 2021 is 2021 minus 1 minus 42 minus 46. Simplifying this, we will get the answer of 1932. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you guys next time. Bye-bye! As a bonus, we actually know what the function is. Note the property over here. We have the sum of phi of d as d for all d that divides n. So phi of d is the Euler's Totient function over here. So the sum of phi of d as D ranges all over the positive divisors of n equals n. So we actually have f of d here to be exactly phi of d. So in this regard, we can actually just get phi of 2021. So we want to get the phi of 2021. In the earlier part of the video, since we know that 2021 is a product of two prime numbers, 43 and 47, so phi of 2021 is simply 2021 times 42 over 43 times 46 over 47. So this is just actually 42 times 46, and evaluating this would indeed give us 1932. So this is another way to solve this item, and as a bonus, you guys have this additional property. So the summation of phi of d as d ranges over all the positive divisors of n, that is indeed equal to n. Bye bye.